Welcome to E-Padasala. Myself Dr. V. Ramesh Babu from Kumaragud College of Technology attached with Textile Technology Department. Today we are going to discuss about finishing agents. Finishing agents is very important nowadays, which is going to give the value addition to the fabric or garment what we are going to produce. This value addition is for the functional usage of customer. So in this class we are going to discuss flame retardant agents and UV protective agents, antimicrobial agents, antistatic agents and pilling agents. So these are all very important finishing agents, each and everyone having its own functional properties which is going to enhance the comfort of the wearers. So we are going to see one by one. So first we are going to discuss flame retarding agents. The flame retardant nowadays getting vigorous development of new technologies and new products and materials to meet the challenge of the needs of the new industries such as computer, electronics and telecommunication industries. Flame retardants are also used in healthcare settings, intravenous pumps, hospital beds, hospital curtains. An additional challenge is the growing awareness of environmental issues and stiffening demands of consumer safety, which has been put forward by government and public agencies. New flame retardant systems are needed to meet the new product and market demands. So overall, nowadays the environmental concern is very much needed by both domestically and export buyers, because the safety is a primary concern of the consumer or customer. So we have to give flame retardant finish to the fabric or garment to ensure that the fabric which they are going to wear should not catch fire easily. Fire safety is a significant cause of property damage and of death. So as earlier told that because of fire, easily the human skin or human body will be damaged and that going to lead to the death. So to avoid that, obviously you have to treat the fabric with flame retardant agents. To meet the fire safety standards, products made of synthetic material are modified with flame retardant chemicals that inhibit the ignition and spread of the flames. Recently, there has been a great deal of interest in providing effective flame retardant for normally flammable substrates. For example, there is a great interest in the development of flame retardant finish on synthetic fibers like polyester, nylon, polypropylene, etc. without disturbing the desirable physical character of the fiber. So this is very important. If you are going to add any finish on the fabric, that should not affect the molecular structure of the fiber. So that there should not be any strength reduction or other property variations in the fiber. So that we have to take care when we are going to apply the finishes. Textile consists of highly ignitable materials and a primary source of ignition. So always the textile like cotton or silk or wool, so easily that are fire catching material. So to avoid that, we have to treat all the fabric with flame retardant agents, so that going to protect the customer by fire. So functions of a flame retardant. Flame retardants are chemicals are applied to fabrics to inhibit or suppress the combustion process. So the fabric which I am going to apply the flame retardant, the fire should not be easily catch, or whenever there is a glow in the fire, that should be suppressed. They interfere with combustion at various stages of process, example during heating, decomposition, ignition or flame spread. As with any solid, a textile fabric exposed to a heat source experiences a temperature rise. If the temperature of the source is high enough and the net rate of heat transfer to the fabric is great, pyrolytic decomposition of the fire substrate will occur. The products of this decomposition include combustible gases, non-combustible gases and carbonaceous char. The combustible gases mix with ambient air and oxygen. So this is all going to lead to easily spread the fire on the material. The mixture ignites, yielding a flame which is composition and temperature are favorable. So if a temperature is favorable, this is all going to be immediately going to happen and the fire spreads very fast. Part of the heat generated within the flame is transferred to the fabric to sustain the burning process, and part is lost to the surroundings. Mechanism of flame retardancy. Flame retardant systems for synthetic or natural polymers can act physically and or chemically by interfering at particular stage of burning. So both physically and chemically, the chemical or the agents which you're going to apply will act to reduce the flaming tendency. So there are some mechanism by cooling endothermic process triggered by the flame retardants cool the substrate by forming a protective layer. So either by cooling or by forming a protective layer on the material, the heat transfer is impeded, clear pyrolysis gases are evolved and oxygen is excluded. By dilution, substances which evolve inert gases on decomposition dilute the fuel in the solid and gaseous spaces. The concentration of combustible gases fall under the ignition limit. Reaction in the gas phase. The free radical mechanism of combustion process which take place in the gas phase could be interrupted by flame retardants. Reaction in the solid phase. One mechanism is the accelerated breakdown of the polymers. Types of flame retardants. There are so many types available in the market. Few are listed in the slide. Brominated flame retardants, chlorinated flame retardants, phosphorus containing flame retardants, nitrogen containing flame retardants, inorganic flame retardants. This can be further classified as inorganic, organophosphorus, halogenated organic and nitrogen based components. Halogenated organic flame retardants are further classified as containing either chlorine or bromine. Types of flame retardants. There are so many types available in the market. Few are listed in the slide. Brominated flame retardants, chlorinated flame retardants, phosphorus containing flame retardants, nitrogen containing flame retardants, inorganic flame retardants. This can be further classified as inorganic, organophosphorus, halogenated organic and nitrogen based components. Halogenated organic flame retardants are further classified as containing either chlorine or bromine. Application of FR. FR is nothing but flame retardant on textiles. One of the most preferred process of applying FR on cotton is pre-condensate and ammonium process. This is an application of one of several phosphonium pre-condensate, after which the fabric is cured with ammonia, then oxidized with hydrogen peroxide. Pre-condensate in the designation for a tetracis hydromethyl phosphonium salt pre-reacted with urea or another nitrogenous material. The amount of anhydrous sodium acetate is approximately 4% of the amount of pre-condensate used. Some pre-condensates are formulated along with sodium acetate. Softness is also added along with pre-condensates. The pH of the pad bath should be approximately 5. The amount of flame retardant required depends primarily on fabric type, application conditions and test criteria to be met. Screening experiments should be conducted to determine the minimum applicable level of fabric. Application for FR for fabric can be accomplished with conventional padding with multiple dips and nips followed by 30 to 60 seconds. Del gives good results. A critical factor in the successful application of pre-condensate NH3 flame retardant is control of fabric moisture before ammonization. Generally, moisture level between 10% and 20% give good results. So these are the various methods of applying flame retardant on the fabric. So we have to be very cautious about pH maintenance and the amount of moisture in the fabric and the time durations. Everything you have to be very cautious, and the amount of flame retardant concentration depends upon the type of fabric and what we are going to apply and what is the final test criteria that we have to meet as per the buyer requirement. So the second agent is antimicrobial agents. The inherent properties of textile fiber provide room for growth of microorganisms. This is obvious whenever this textile material kept in storage or warehouse because of high humidity or some wetting take place. These microorganisms will develop on the fabric. Besides the structure of the substrate, the chemical process may include the growth of microbes. So the two factors influence the microbial growth. One is the fabric structure and the chemical reaction happening because of high moisture. Humid and warm environment still aggregative problem. So here either very high humidity or high warming condition leads to chemical reaction. So microbes easily grown in the material. Infestation by microbes cause cross infection by pathogens and development of odor where the fabric won't next to skin. So the second problem is whenever the microbes are growing in the fabric, that going to give the bad odor to fabric. This all should be arrested by applying the antimicrobial agents. In addition, the staining and loss of performance or properties of textile substrate are result in microbial attack. Basically, with a view to protect the wearer and the textile substrate itself, antimicrobial is applied on the textile material. So to protect the wearer, so wearer should not get any skin infection, and the basic raw material textile fabric should not be lost in their property. So for this two purpose, we are applying the antimicrobial agent. Necessity of antimicrobial finishes. Antimicrobial finishes treatment for textile material is necessary to fulfill the following objectives: to avoid cross infection by pathogenic microorganism, to control the infestation by microbes, to arrest the metabolism in microbes in order to reduce the formation of odor, to safeguard the textile product from staining, decoloration and quality deterioration. So this is very important because of microbes affecting the fabric. The color maybe staining will be happen in the fabric, or the color will be degraded, or the quality of the material like strength loss or other issues going to be happen on the fabric. This should be arrested by applying the antimicrobial finishes. So what are the various requirements for antimicrobial finish? Textile material, in particular the garments, are more susceptible to wear and tear. It is important to take into account the impact of stress, strain, thermal and mechanical effects on finished substrate. The following requirements need to be satisfied to obtain maximum benefit out of the finish. Durability. So any finish if you are going to give, that should be long lasting. After 30 or 40 wash, that should be durable in the fabric. And in dry cleaning, hot pressing. Selective activity of undesirable microorganisms. So sometimes microorganism leads to some other effect on the fabric or wearer, that should be avoided. Should not produce harmful effect to the manufacturer user, that is very important. And environment too. Should comply with statutory requirement of regulating agencies, that is very important. Every country having their own requirements or mandatory requirements that should be fulfilled by applying this finish. Compatibility with chemical process. So the finish which I am going to apply should not react with further chemical processing, that should not give the adverse effect on the fabric. Easy method of application, no deterioration of fabric quality. Resistant to the body fluids, resistant to the disinfection, sterilization. These are the various requirements for antimicrobial finish. So what are the various methodologies of applying this antimicrobial finish? The antimicrobial agents can be applied to the textile substrate by exhaust, pat dry, cure, coating, spray and foam techniques. So all techniques are suitable for applying this finish. The substances can also be applied by directly adding into the fiber spinning dough. So this is the another method where whenever we are going to spin the fabric by using polymer stage itself, we can add in the polymer. It is claimed that commercial agents can be applied online during the dyeing and finishing operations. Once all the processes are over, the fabric is ready for final stage. That time also, or during dyeing or in the finishing operation also, you can add the antimicrobial agents. Various methods for improving durability of finish include insolubilization of active substance on the fiber, treating the fiber with resin condensates for cross-linking agents, micro encapsulation of the antimicrobial agents with the fiber matrix, coating the fiber surface, chemical modification of fiber by covalent bond formation, use a graph polymers, homopolymers and or copolymerization on the fiber. So these are various technology used to incorporate antimicrobial finish on fabric or in the fiber also. So this picture shows the mechanism of antimicrobial activity. So when you see the picture, antimicrobial finish, A, hygienic finish on clothing and textile, antimicrobial finish on technical textiles. So you are going to have antibacterial and antibiotic. So here bactericide, germicide and fungicide. Bacteriostatic, deodorizing and fungistatic. So either we can, that is called cidal or cide, destruction of microbes. Here we can, already the microbes are grown in the fabric, that we can attack by this finish and we can destroy that microbes, or in static, inhibition of microbe growth. Otherwise, we can arrest the growth of microbes on the fabric. So either we can control this antimicrobial happenings on the fabric. So antimicrobial textiles. Actic guard finish from Clarent. So Clarent is a very famous company for chemical manufacturing. So they having the brand called Anti-Guard are used in carpets to combat action of bacteria, house dust mites and mold fungi. Avicea S. Purishita branded products treated with Reputex 20, which is based on polyhexamethylene biguanide hydrochloride, that is called a PHMB, claimed to possess low mammalian toxicity and a broad spectrum activity activity. PHMB is particularly suitable for cotton and cellulose textiles and can be applied to the blends of cotton with polyester and nylon. The third one is antistatic finish. Antistatic finish are used for removal in synthetic fiber for unwanted effects of electrostatic charge produced during production and wear of the fabric and nets. So this is mainly for synthetic fabric. The synthetic fabric is having the tendency of material will be charged, so that going to affect the dust and dirt on the fabric. Electrostatic charge causes an undesirable adhesive power and a resultant sabbiness. So the fabric will be stick each other. It is applied by means of an antistatic chemical treatment, the effect of which may be temporary or permanent. There are two types of antistatic finish. One is non-durable finish and durable finish. Non-durable finishes. Non-durable antistatic agents are preferred for fiber and yarn processing finishes since ease of removal is important. So easily after 1 or 2 hours it will be easily removed from the material. Other important requirement of swing finish and fiber lubricants are heat resistance and oil solubility. This group of mostly hygroscopic material includes surfactants, organic salts, glycols, polyethylene glycols, polyelectrolyte, quaternary ammonium salts, and fatty alkali chains, polyethylene oxide compounds, and ester salts, and alkali phosphonium acids. The general requirement of non-durable antistats are low volatility, low flammability, non-alloying, non-corrosive, low foaming. The second one is durable antistat. Obtaining antistatic properties that are durable to repeated laundering for a single finish application is difficult to achieve. The basic principle is to form a cross-linked polymer network containing hydrophilic groups. Typically, polyamines are reacted with polyglycols to make such structures. These polymers can be formed prior to the application of fabric, or they can be formed in situ on fiber surface after FAD application. Mechanism of antistatic finish. The principal mechanism of antistatic finish are increasing the conductivity of the fiber surface equivalent to the lowering the surface resistivity and reducing the frictional force through lubrication. So here we are increasing the conductivity of the fiber surface by applying the antistatic agents. Antistatic agents that increase the fiber conductivity form an intermediate layer on the surface. That is very important. That going to form the intermediate layer between the fiber and other material. This layer typically hygroscopic. The increased moisture content leads to higher conductivity. Most non-polymeric antistatic finishes are also surfactants that can orient themselves in specific ways at fiber surfaces. Application of antistatic finish. Although antistatic finish applied after dyeing or printing is more common with hydrophilic fibers, fabrics and made from cotton, rayon and wool may also be antistatic treated depending upon the intended use. The textile products that are treated with antistatic finish includes carpets for computer rooms, upholstery fabric and airbags for automobiles, conveyor belts, filtration fabrics, airmail bags, parachutes, fabric for hospital operating rooms, and protective clothing for work with flammable gases, liquids and powdered solids. Anti-pilling agents. Other finishing agents commonly used in the fabric. The pilling is one of the major quality problem in spun-yarn fabric, particularly made from synthetic fibers and their flames. This problem is not for a continuous filament yarn, this is for spun-yarn fabric. Pilling is the fabric defect which appears as small balls attached to the fabric surface by fibers. These balls are quite different from the balls observed frequently with the textured filament yarn fabric. The pills are formed only during the wear and washing due to the abrasion affecting appearance, touch and handle of the fabric. So here the appearance of the fabric goes off and the feeling, the handle of the fabric goes off. Disposal of the garment long before they reach their normal wear life results in customer dissatisfaction. This is whenever the pills are formed on the fabric or garment, we cannot wear the garment because of bad look. So the customer dispose as early. So the customer will be get dissatisfied. Anti-pilling chemical finishes. Different chemical finishing approaches have been made to prevent pill from accumulating on the fabric surface, which include the following: application of polymers by padding and coating technique, reduction in strength of fiber to reduce pilling to cause the pills to fall off from the material as soon as get formed, application of enzymes, that is called biofinish, to 100% cotton textiles to cause removal of loose fiber in the yarn to reduce the pilling tendency. So these are the three ways or methods to apply the finishes on the fabric to enhance the anti-pilling character of the fabric. Anti-pilling chemical finish, the polymeric formulation bring about the binding of loose fiber into the fabric. The products normally used in this type of finish are friction reducing lubricants to minimize damage due to the abrasion. The acrylic copolymers, the fabric from the yarn spun from fibers of lower strength, shows significant improvement in pill rating as compared to the fabric made from normal polished fiber. In the third approach, biopolishing with cellulose enzyme is carried 100% cellulose or cellulose rich blend fabric to eliminate loose fiber, which results in clean and smooth surface with improved pilling rating. The final finish what we are going to discuss is ultraviolet protective agent. This is nothing but long-time exposure of UV light can result in acceleration of skin aging and aging, phototoxic reaction to drugs, skin reddening, sunburn, increased risk of melanoma, that is skin cancer, eye damage, and DNA damage. So these are the problem when you are going to expose to the sunlight. This will be arrested or should be reduced by giving finishes to the fabric to enhance the ultraviolet protection. So UV finishes. UV protection ability of textile material are influenced by type of dye or pigment, the absorptive group present in the dye stuff, depth after dyeing, the uniformity of additives present in the finishes. The protective effect can be obtained by dyeing, printing or finishing, which is better than using heavyweight fabric which are not suitable for summer condition. So while doing dyeing or applying color, generally the dark colors, black, navy, dark red of same fabric type provide better UV protection than light pastel colors. For instance, UPF, that is ultraviolet protection factor for green color t-shirt is 10 versus 7 of white. However, particular dyes can be vary considerably in degree of UV protectiveness because of individual transmission and absorption characteristics. Some direct and reactive and wet dyes are capable of giving UPF of 50 plus. In many cases, UPF calculated using direct dye solution appears to be higher than the fabric after dyeing. Dye extracted from the various natural resources also shows the UPF within the range of 15 to 45 depending on the modern fuels. So natural dyes always having better property compared to the synthetic dyes. So UV stabilizers. Several types of UV stabilizers available, the most common being benzopenones and phenyl benzotriazoles. These molecules are able to absorb the damaging UV rays of sunlight. Classification of UV stabilizers. Ultraviolet stabilizers can be classified into three different categories depending on their mode of action. The UV absorbers. The amount of UV radiation absorbed by the polymer upon natural weathering can be reduced substantially by using additives which compete with the photosensitive chromophores of polymer substrate for absorption incident photons. The UV absorber providing long-term stabilization against UV radiation without any getting destroyed. UV absorbers are organic or inorganic colorless compound which very strong absorption UV range of 290 to 360 nanometer. UV absorber incorporated in the fiber convert electronic excitation energy into the thermal energy. They function as radical scavengers and oxygen scavengers. The high energy short wave UV excites and UV absorber to high energy absorbed may be distributed as long as wave reduce. Alternatively, isomerization can be occur and the UV absorber may then fragment to the non-absorbing isomers. The other one is quenchers. The excited chromophores responsible for photooxidation can be transferred the energy to the adequate acceptor or quencher before chemical bonds are broken and radical initiated reaction proceed. The commonly used light stabilizer of this kind are organic complexes of transition metals like FeCl, etc. The inherent color of this metal complex is a distinct problem which limits the use of stabilizer for white and clear polymer materials. The third one is hindered amine light stabilizers. It is called HALs. The derivatives of 2,2,2,6-trimethyl piperidine are called HALs. HALs protects polymer chemically, not physically, and their effectiveness depends upon the optimum dispersal in the binding agents. The basic principle followed here is they form nitroxyl radicals in the reaction with hydroperoxide. The nitroxyl radical react with free radical in polymer backbone, form amine ethers. The amine ethers terminate peroxy radical to cause reversion of nitroxyl radicals. So in this class we have discussed various finishing agents such as flame retarding agents, antimicrobial agents, UV protective agents, antistatic agents, anti-pilling agents, and so on. So each and every one has its own functional properties which going to give the functional finishes on the fabric or garment and enhances the wearer comfort. In case of flame retarding agent, we have discussed what are the various flame retarding agents available commercially, and what is the mechanism of flame retarding agents, and what are the objectives of giving that flame retarding to the fabric. And in antimicrobial finishes we have discussed why it is important, what is the necessity of giving that antimicrobial finish to the garment, and what are the various agents that is readily available in the market. And antistatic, that also very important for synthetic fabric where the dust and dirt will accumulate in the fabric because of static electricity. To avoid that we are giving antistatic finish, and so many finishes are discussed in this chapter. And pilling, again that going to give ugly look on the fabric or garment, which a small ball are formed on the fabric or garment, that should be avoided because of light reflection that will be awkward look to the customer. So to that there are so many chemical finishes given to the fabric to avoid the pilling, and so on. We have discussed so many finishes which going to enhance the wearer comfort, and this all mandatory requirement by the buyer to ensure that customer who going to buy the garment will have all the qualities. Thank you.